Imagine waking up completely conscious, but your body refuses to move. A shadow looms, your chest feels crushed, and you can't scream. This is not a nightmare, it's sleep paralysis, and neuroscience finally explains why. Sleep paralysis is a strange and terrifying phenomenon where the mind wakes up, but the body remains locked in sleep. It occurs when the brain transitions incorrectly between sleep stages, specifically when it emerges from REM sleep while the body stays paralyzed. This state leaves the individual fully conscious, yet unable to move a muscle, often accompanied by vivid and frightening hallucinations. Epidemiological studies show that about 7.6% of the general population has experienced at least one episode, with rates much higher among students and psychiatric patients. Despite its prevalence, it remains one of the most misunderstood conditions in sleep medicine. For centuries, cultures around the world have interpreted these episodes as demonic attacks, alien abductions, or witch curses. But modern science reveals a fascinating glitch in the brain's sleep-wake machinery. To understand sleep paralysis, we must first understand REM sleep. During REM, the brain is nearly as active as when awake, and most dreaming occurs. To prevent us from acting out our dreams, the brainstem sends signals that inhibit motor neurons, paralyzing nearly all voluntary muscles, a state called REM atonia. Sleep paralysis happens when the mind wakes from REM, but the body remains in atonia. Neuroimaging studies reveal that during an episode, the prefrontal cortex is partially activated, allowing rational thought, while the motor cortex stays inhibited. This creates a unique state. You are awake enough to think, but your body is still locked in the dream state. The brainstem's pons and medulla oblongata play a central role, sending inhibitory signals mediated by glycine and GABA. The delicate balance of neurotransmitters is crucial for smooth sleep-wake transitions. Acetylcholine promotes REM sleep, while serotonin helps stabilize the sleep-wake cycle. When these systems fall out of sync, the brain may awaken while the body remains paralyzed. Research by Jalal and colleagues shows that disruptions in acetylcholine and serotonin contribute to sleep paralysis. This neurochemical imbalance may explain why the condition is more common in individuals with anxiety, depression, or PTSD, conditions that alter neurotransmitter function. The inhibitory system remains active even as the cortex wakes up, leaving the individual trapped. Understanding these chemical underpinnings offers hope for targeted treatments that could restore balance and prevent episodes from occurring. Perhaps the most terrifying aspect of sleep paralysis is not the paralysis itself, but the vivid hallucinations that often accompany it. These are not ordinary dreams, they feel as real as waking life. Researchers have identified 3 categories of these hallucinations. The first is intruder hallucinations, where a threatening presence is perceived in the room, often as a shadowy figure, demon, or alien. In a landmark study by Chain and colleagues, 75% of participants reported this experience. The brain's hypervigilance system, led by the amygdala, detects the inability to move as a threat and generates a narrative of danger, projecting an external cause for the internal fear. This creative terror is a direct result of the brain trying to make sense of a confusing state. The second category of hallucinations involves a crushing weight on the chest, often accompanied by difficulty breathing. This is historically interpreted as being sat on by a demon or witch, known as the incubus or night hag. Neurobiologically, this sensation arises from REM atonia, relaxing the intercostal muscles used for breathing, combined with the brain's threat detection system. When the brain senses restricted breathing, it generates a narrative of suffocation, personified as a supernatural entity. The third category, vestibular motor hallucinations, involves sensations of movement or floating, flying, falling, or leaving the body. These out-of-body experiences can be induced by stimulating the temporoparietal junction, a brain region that integrates sensory information, showing how the brain constructs our sense of self. Throughout history, cultures worldwide have interpreted sleep paralysis through supernatural lenses. In medieval Europe, it was blamed on demons like the incubus and succubus. In Newfoundland, it is called the old hag, a witch that sits on the sleeper's chest. In Japan, it is known as kanashibari, a form of magical paralysis by spirits. In Egypt, it is attributed to jinn. These diverse interpretations highlight the universal human need to explain unexplained experiences. Modern neuroscience now offers a biological explanation, but the cultural stories persist, adding layers of fear and meaning. Understanding these cultural contexts helps researchers appreciate how deeply sleep paralysis affects individuals and why it has been so misunderstood for centuries. For those who suffer from frequent sleep paralysis, there is hope. Emerging treatments focus on stabilizing sleep patterns and addressing underlying conditions. Cognitive behavioral therapy can help reduce anxiety and disrupt the fear cycle that often triggers episodes. Improving sleep hygiene, consistent sleep schedules, avoiding caffeine and alcohol before bed can prevent the fragmented sleep that leads to paralysis. Some researchers are exploring pharmacological options that target neurotransmitter imbalances, such as selective serotonin reuptake inhibitors, SRI, which can help regulate sleep-wake cycles. Lucid dreaming techniques have also shown promise, allowing individuals to recognize the state and reduce fear. While more research is needed, these approaches offer a path to reclaiming peaceful sleep for millions. Sleep paralysis reveals the incredible complexity of the brain's sleep machinery. If you found this exploration valuable, consider sharing it with someone who might benefit from understanding this mysterious phenomenon.